Good morning, students. Today let us see about PMMC and Mi instrument. So generally these type of devices are used. It may be used as ammeter and as well as voltmeters. So type of ammeters and voltmeters. One is permanent magnet moving coil type instruments. We call it as PMMC. One is moving iron instruments, Mi instruments. So these Mi can be classified into attraction type as well as repulsion type. So permanent magnet moving coil, it may be ammeter or it may be voltmeter. So whenever a current conductor is placed in a magnetic field, it experiences a force and tends to move in as per the direction of Fleming's left-hand rule. So if the first and second fingers and the thumb of the left finger are held so that there are right angles to each other, then the thumb shows the direction of force on the conductor. The first finger points towards the direction of the magnetic field and second finger goes the direction of the current in the finger. So construction, a coil of thin wires wounded on aluminum frame positioned between poles of the U-shaped magnets, which is made up of magnetic alloy like anillo. So the coil is pivoted on the Joul's bearing and thus the coil is free to rotate. So the current is fed to the coil. Whenever the coil experiences a force, the magnetic field will be produced by the permanent magnet and the pointer toss attached to the spindle, which measures the values. So this shows the internal structure of the PMMC here. As I told, there is a pointer indication on the coil, and then there is a coil which has been placed lower hairspring and upper hairspring support coils to the coil, iron core, and then there is a pole piece. So this shows the structure of the core, not pole, south pole, and then spring, weight, pointer, deflection, scales. So this shows the top view where the radiation field is being generated here. So when a current flows to the coil, it generates a magnetic field which is proportional to the current in case of an ammeter. So the reflecting torque is produced by electromagnetic action of the coil. The controlling torque is provided by the phosphorus bronze flat helical spring. The spring causes a flexible connection to the coil, and the damping torque is produced by eddy current set up by the aluminum coil, which prevents the oscillation. So here the deflecting torque Td equal to NBI into Di, which is called Gi, which is constant. We are taking here. The spring constant T is that is the controlling torque T is equal to K into theta. Spring constant K value, and then the steady state condition, the controlling torque must be equal to deflecting torque. So you substitute theta equal to G by Ki. So current I equal to Kg by G. So here we are assuming the values, that is K is directly proportional to theta. So the current is directly proportional to theta. So applications we are using, it can be used as ammeter, it may be used as the moving coil contain a suitable low resistance shunt, small part of the main coils. The shunt consists of number of thin plates made up of alloy metals, which can be used as a ammeters. So this shows the ammeter image and voltmeter. So PMMC can be used as a voltmeter. The coil is connected in series with the high resistance, so it can be used for the measuring the voltage values. So it can be used as a galvanometer, very small value of current, which is direction and the strength. So it is mainly used abroad to detect the compare the different circuits in the system. So ohm meter. So as I told, it is used to measure the resistance values by applying a voltage to a resistance with the help of batteries. So generally galvanometer scale is marked in the ohm as the resistance value. Since the voltage is fixed to the meter, it may be used as a ohm meter. So advantages. So PMMC consumes less power and great accuracy. It has the divided scale and over or PMMC has high torque to weight ratio, modified ammeter as well as it or voltmeter, suitable resistance. So damping characteristic is not affected by stable magnetic field. It produces no losses due to hysteresis. So disadvantage is used only for DC measurement. It cannot use it for AC measurement. Delicate and sometimes used for AC circuits with rectifiers. Costlier as compared to moving iron instruments. Shows here due to loss of magnetism of permanent magnets. So next one is moving iron instruments. So it may be another type which can be used as a voltmeter and ammeters. So generally used to measure alternating voltages and currents. So moving iron instruments are movable, consist of one or more pieces of specially shaped soft iron, which so provided as to act upon the magnetic field produced by the current in the coils. So there are two types. One is repulsion type, one is attraction type. So moving element is soft piece of iron in the form of vein or rod. So the coil is magnetic field due to current flowing through it and allows to magnetize the iron pieces. So repulsion type of fixed vein or rod is used and magnetized with the same polarity. So controlling torque is supported by spring or gravity, that is weight, gravity method we are using here. Our damping torque is normally pneumatic. The damping device consisting of air chamber and moving vane attached to the instrument spindle. So deflecting torque produces a moment on the aluminum pointer over a graduated scale. So this shows the repulsion type. So repulsion type, which has use a moving vane, fixed iron vane, and then there is a pointer which is connected to hair spring and the shaft, and then the fixed cylindrical coil, and coil leads to meter terminals. Similarly, attraction type we are using the same thing, coil, both the sides of coil and the circle moving iron is mounted eccentrically, the controlling weight for gravity control and balancing weight to maintain it, and piston and air damper chamber for producing the damping torque produced here. So the attraction process, it tries to move the pointers. So that is the deflecting torque is one of the Mi due to forces of small pieces soft iron that is magnetized by current coil in an operating current. So repulsion type, it produces the repulsion of forces of current passing to the coils. It may be used as the ammeter or it may be used as the voltmeters. So applications, it may be used for voltmeter as well as ammeter for measurement of both AC as well as DC. So ammeter measures current values, always is connected in series with the circuit to measure the current. So current flowing through coil produces the deflecting torque. It shows low resistance. So voltmeter measured between 2 points connected in parallel. Current flows through operating coil, which produces the deflecting torque. It has high resistance when compared to measuring the voltage values. So advantages used for both AC and DC. The instrument are robust owing to the simple construction. Stationary part of the instruments are also simple. Instrument is low cost compared to moving coil instruments. The torque weight ratio is high. It reduces the frictional errors. Thank you.